Hello, welcome to Picture Me Coding with Erik and Mike Mull. Hi, Mike. Good morning.
Hey there. Good morning. Did you know, Eric, that this is our 100th episode of Picture Me Coding?
I only knew because you told me, and I was a little bit shocked. 100 episodes of this show, music podcast about software. That's crazy.
Yeah, it's funny because when we started, we sort of decided that if you make 100 episodes, you can officially say, I made a podcast.
So I could introduce myself that way at parties. I have a podcast. That's a
Yep.
good way to earn new friends, I bet. People immediately want to talk to you and not run the other way.
It seemed like a long way away when we started, just a little bit less than 3 years ago. So July will be our third anniversary. So we made it.
It's kind of amazing. 100 episodes. Wow. It's been fun. I've learned a bunch of stuff and I've already forgotten a bunch of stuff, sadly.
Same. I've learned things, but I look back at our old episodes and I think I should revisit that because I've kind of forgotten what that was about.
I should relearn that thing I learned. People will say stuff to me like, oh yeah, you talked about it on this episode. And I was like, did I? Yeah, that sounds familiar. Wow, that's really cool. I wish I knew what that was. And I'm like, I did know what it was at one point.
Some of these things have stuck with me.
Yeah, me too.
Like I got pretty deeply into query optimization, and I think that will be in my brain forever now. But I'm not sure I could go back and give you details on like the Lynch stuff, the CAP theorem.
The distributed system stuff stuck with me a lot more for some reason.
I really like those CAP theorem episodes, but I'm not sure that I could spin out all the details that we had.
You feel more like a fan than a participant. Have you been listening to music lately, Mike?
I have. There's a new Jeff Parker album out. Jeff Parker.
I loved that first one. That other one that you told me about.
Can't remember how long ago it was. I think it was 2024. He and this ETA quartet had an album out called The Way Out of Easy, which I really loved. And they have a new one out just in the last couple of weeks called Happy Today. It's only 2 tracks, but it's 44 minutes long. So like all of their other stuff, it's recorded live and it's kind of improvisational. So I don't know how improvisational. I assume they go in with some sort of idea what they're going to do, but I like jazz generally, but there's something about what he's doing and this quartet is doing that is just sounds different to me.
Yeah.
That I really like.
The Way Out of Easy, I had that same experience where I was like, wow, there's something really fresh and vibrant feeling about this. Like it feels new and interesting. There's something they're doing that really grabs me.
Yeah, and it's got this interesting mixture of being interesting and challenging, but not feeling like a test. some modern jazz where it's like, I'm going to play something so weird that you're probably not going to get it, but
you're talking about free jazz, probably. Yeah, I've never gotten it. I don't know. Like, there's always this like Coltrane cutoff.
Yeah,
people whose opinions I respected would be like, "Oh, you got to listen to this Coltrane," and it'd be like Coltrane 65, and I'd be like, I don't know. I don't think I want to like it, but I cannot. I've been listening to this band from Australia called Swap Meat. They're young. They were just teenagers when they started the band in the 2020s, Mike, if that makes you feel old. They have an EP called Oxalis they came out with a couple years ago. I just found out about it a few weeks ago. I don't even know how it came up. The EP is 5 songs, and they have a full-length album coming out this summer. But the reason I love this band is they sound exactly, when I heard them, like exactly like the band I wanted to create in the 90s. Like as soon as they came out, I was like, oh my God, they did it. This is the sound I wanted. It's like this kind of Rodin. You listen to Rodin, right?
I have, yeah.
Yeah. Rodin, Pavement, indie rock, but a little bit kind of on the edge, pretty fuzzy, pretty like about to like sort of careen out of the, I don't know, it's like a top wobbling around, it's going to fall over. They're just kids, but it's like 30 years after I wanted to start this band, these kids made this sound. These kids from Australia, they made the sound I wanted to hear. And I feel like, yes, keep making that music. So I'm looking forward to the thing comes out this year.
Is this what Puke Wizard would sound like?
No, Puke Wizard was my name for a stoner doom band. but I don't know. I never had enough. I mean, I had some stoner doom friends. We kind of played music a little bit, but it didn't really work out.
I would have to be the singer in the Stoner Doom band because I don't play guitar.
So, Mike, I got blocked out of our podcast at Picture Me Coding email address over the last month. If you have emailed us recently, I apologize. We have not really been actively responding. I forgot to pay the bill for the hosting. It's not expensive. It's like $10 a year, but this allows me to plug and say thank you to our Patreon supporters. If you'd like to support the show, if you like what we're doing, we do have a Patreon subscription, $4 a month. It's pretty affordable. It helps us pay for things like email subscription, which I plan not to forget in the future. That's our Patreon, Patreon at Picture Me Coding. So thanks to all of our subscribers. Thank you guys. You're helping us host the show on the internet and host our email. And people can reach out to us at podcast@picturemecoding.com.
You should ask your personal assistant to set a reminder to remind you of that.
I don't have a personal assistant. I have a 12-year-old, but he's like, I mean, it takes a lot to get him to just brush his teeth. So I got a feeling he's not going to be crappy at that too.
100 episodes. The interesting thing about 100 episodes is the number 100.
Yeah. We got to do like a big party here, big jam band celebration.
I think we're probably just going to play march music for the rest of this episode. And basically, we decided that since this is an interesting number, totally arbitrary, because we have 10 fingers and we like powers of 10, that we would talk about numbers on this episode. So officially, this episode is titled Numerology.
So this is a big number. So we figured we should do something special. So let's talk about numbers.
And as you will find out in the course of this episode, we weren't quite sure what that meant. We got some good stuff for you anyway.
Well, but you were like, do you have any favorite numbers? And I was like, should I?
And I was like, how could you not? You're a grown-up. How could you not have acquired favorite numbers by this age?
I mean, I started remembering. I mean, I had favorite numbers as a kid, but I started remembering all this random stuff I've memorized over the years.
Here's my first weird numerical fact, which is sort of computer related.
Okay.
The ENIAC, which was by some accounts the first digital computer, was base 10. Did you know that?
I did not know that. That sounds way easier than binary, though, Mike.
They thought it would be. They built it. Mechanical calculators at the time were base 10, so they figured it would be easier to build an electronic digital computer with base 10, and they turned out to be wrong.
Can you tell me why it was wrong, though?
Not really.
Okay.
They thought that it was going to. They actually thought that it was going to make the circuitry easier, and it turned out to be more difficult circuitry and more vacuum tubes than they would have used if they had used binary.
Oh, okay. Yeah.
So most subsequent computers, like the EDVAC computer that was described by von Neumann, obviously switched to base 2.
When you start talking about numbers, the first thing I thought of was numerology, which is like magical numbers, like attributing significance to numbers. There's a pretty cool Wikipedia entry on numerology where they describe it. This is a quote from Wikipedia. Numerology is the belief in an occult, divine, or mystical relationship between a number, a metaphysical phenomena, or ideas. It is also the study of the numerical value of the letters and words and names. For example, gematria. There's all those rad words I've never heard. Gematria. When numerology is applied to a person's name, it is a form of, and this is another rad word, onomancy. What a great word that is. It's often associated with astrology or other divinatory arts. Sidebar, onomancy, I looked that up. It's a form of divination that predicts a person's fortune or destiny by analyzing the letters and numerical values in their name. So we could take your name, Mike Mall, and 20 years ago have turned it into some numerical formula which would have predicted that you'd have a podcast.
I wonder if you can get a degree in onomancy.
Onomancy. What a good word that is. What a cool word. Oh no, it's onomancy. That's a bad joke.
Being a professional onomancer would be would be an interesting profession.
Well, there's this note towards the bottom of the Wikipedia entry on numerology where they say that scientists sometimes will like cast aspersions on other scientific work and say, "Oh, that's just numerology." Like they'll use it to dismiss stuff as you're just looking at patterns and numbers. That's just That's just magic and woo woo tea leaf reading bullshit. Like those are meaningless. Those are the numbers. But then they have all these funny examples. Paul Dirac, Herman Weyl, and the astronomer Arthur Stanley Eddington. They had this. They realized there's this coincidental resemblance of certain large numbers, and so like the ratio of the age of the universe to the atomic unit of time, the number of electrons in the universe, difference in strength between gravity and electric force, or electron force. So they were like, wow, look at all these numbers and how closely aligned they are. There must be something here. And I guess Wolfgang Pauli was really fascinated by certain numbers, like 137. I don't know if that one means anything to you, Mike.
Paul is an interesting case. He had this fascination with the number 137, and he also had this long association with Carl Jung,
Oh,
the I guess psychologist, and
yeah, a disciple of Freud, I think.
yeah, and they were kind of collaborating on this Jungian idea of synchronicity. Pauly, in particular, had this fascination with the number 137, and he would apparently dream about it. And the only real connection that it seemed to have to physics was that there's a number called the fine structure constant, which is roughly 1 over 137. Yeah, Wolfgang Pauli was a well-known and legitimate physicist who was known for, what I learned in undergraduate physics as the Pauli exclusion principle. So he was not a crackpot, but he had this obsession with this number and would dream about it. And I've even read possibly apocryphal stories that when he died, he was in hospital room 137. So
That's a little bit surprising. So when if we get to episode 137, if we have not retired from the podcast game by then that'll be the Wolfgang Pauli episode, right?
it's a good idea.
You actually have some favorite numbers. I don't have any.
I do, and I'm not sure why I do.
I want you to try to convince me that my life is devoid of meaning from not having favorite numbers.
So when we were talking about this episode and what we were going to include in it, it was just around the time when the Department of Justice had filed this sort of ridiculous indictment against James Comey, the former director of the FBI, because he had posted this thing that he found on the beach, allegedly, which was somebody had constructed the number 8647.
Oh, out of seashells on the beach.
Out of seashells, right? Yeah.
Yeah, this is a weird story.
The number 86 has long been used as a sort of euphemism for get rid of, and I don't know exactly what the origin of that is. So
it comes from restaurants.
Oh,
they would say 86 something like no longer serving this dish, we're out of the lobster.
Gotcha. So 8647 is then allegedly code for getting rid of 47, who is Donald Trump, because he's the 47th president.
This sounds like numerology, though, Mike. This sounds like there's
total numerology. But because of this weird compulsion I have, I said that looks like a prime number to me. So
yeah, that's right. And I said, like a hate crime prime. And you came up with this you came up with this thing right away, and I was like, oh, that's cool. I want to remember that.
Yeah. So we invented hate primes.
You invented. Hey, you were like, yeah, like a hate prime, and I was like, oh, I got to remember that hate primes.
So 8647 is indeed prime, and it's the first of what we are calling hate primes. We haven't found another one yet, but I'm sure there are some. So let us know if you have some. Some other good ones. Go ahead.
Primes come up a lot when people have favorite numbers. I mean, I don't have any favorite primes, but I kind of find the twin primes conjecture to be interesting.
Yeah. I mean, prime numbers are interesting. Integers in general. There's like literal books full of. I think there's websites too where they have, here's what's interesting about this integer, and they, give some reason why that particular number is interesting. It's prime, or it's a square or whatever. It was interesting. We were reading a while back. We were reading "I Am a Strange Loop" by Douglas Hofstadter, and he was talking about this phenomenon. And
Yeah.
He was talking about these two books, both of which list interesting things about all the integers up until some level. And
Yeah, one of our listeners was writing to us about Gödel Bach too, the Hofstadter book. I think that was maybe it was Forrest who was writing to us about that. A shout out to Forrest there.
oh, that's right, yeah. So every time I turn a new age, I try to figure out if there's something interesting about the number. And
Mm-hmm.
my last birthday was 62, so I'm eligible for Social Security now. Yes. I decided to figure out what was interesting about that number, and I came across this thing in I Am a Strange Loop where he was talking about these two references that list interesting things about numbers. There's this line in there that says, "So then I decided to find the lowest integer that both books considered to be utterly devoid of interest, and this turned out to be 62."
You're saying that that's the least interesting number according to Hofstadter.
Yeah,
Cross-referencing.
it's the lowest integer, which is quote utterly devoid of interest. So anyway, I wouldn't include that as my favorite number, but I
And
would.
then it goes into your happy birthday speech, into your birthday speech. You stand up at the table. I've now achieved the lowest uninteresting number.
I am now officially devoid of interest.
You have an actual favorite set of numbers.
Yeah, so I've got a few here. My actual favorite number, and this has been a number that I learned about a long time ago, probably in high school, and have been using in passwords for the last 50 years.
Uh-oh,
But
that was bad OPSEC there, Mike. But go ahead.
so the number is 1,729. And there's very likely people out there who've already heard of this number because it's the subject of a famous anecdote by the mathematician G.H. Hardy and his relationship with the famous Indian mathematician Ramanujan. The story goes that, Hardy had brought Ramanujan to Cambridge to study with him, and Ramanujan got sick, and Ramanujan was in the hospital, so Hardy went to visit him. And when Hardy got to Ramanujan's room, he said, "I came over in cab 1729, and it just doesn't seem like a very interesting number to me." And according to the story, Ramanujan immediately says, "Actually, it's very interesting. It's the smallest integer that can be expressed as the sum of two cubes in two different ways." The number 1729 is 1 cubed plus 12 cubed, and also 9 cubed plus 10 cubed.
I don't know, Mike. 1729, two cubes, two different ways. Okay, it's cool that Ramanujan pulled that out off the top of his head, I guess. But
yeah,
I don't know.
that's the part of it that I enjoyed. The next one is 2600. This one doesn't
like
have
Atari 2600. I had one of those when I was a very wee little lad.
There was also an Atari 2600, but this one goes back to my early days of computing when people were still trying to mess with the phone system.
Mm-hmm.
And somebody discovered that if you produced a 2600 hertz tone on the phone, it would put you into what they called operator mode.
Oh, the phone freaks, right?
Yeah.
Early hackers.
Yeah, so there was this early group of hackers who messed with the phone system that people called phone freaks. And there was this one guy who discovered that he could produce this 2600 hertz tone using a whistle that he found in a box of cereal.
Yeah, Captain Crunch. That was his name, right? Captain Crunch.
After that, they called him Captain Crunch.
Yeah.
And then, because of this association, there was this hacker zine that was published for many years that was called 2600. So this one's a bit more like computer history and computer lore than mathematically interesting.
Yeah, see, that's like when you say favorite number, I don't know. I guess 2600 hertz. Like I have random stuff memorized. I have the numerical identifiers for my favorite NOAA buoys memorized. That's pretty weird, I guess. Is that weird? That's probably pretty normal if you look at the buoys a lot and you're like, oh, that's my favorite buoy right there. That one knows the business. Yes, yes, the sea surface temperature is 64 degrees Fahrenheit. Give me more. My favorite buoy.
The next one is one that I got from my son. So I can't really count this as one of my favorite numbers, but I think it's a cool idea. The number is 7,825. It comes from a famous proof that has to do with what's called Ramsey theory.
Hmm.
So 7,825 is the smallest positive integer with no two coloring that makes Pythagorean triples monochromatic.
Oh, that's a dense sentence. Two coloring.
Yeah, so let
Pythagorean
me.
triples, a squared plus b squared equals c squared.
That's right. So
Monochromatic is one color. The one color, two coloring, one color. What is what? I don't understand.
So the idea is here you've got this sequence of integers, and you can assign them one of two colors. Arbitrary, it could be red and blue or any other two colors you like. And
Mm-hmm.
inside that set of integers, there are going to be subsets which are what are called Pythagorean triples, meaning that they are sets of integers where a squared plus b squared equals c squared. And at some point,
3, 4, and 5, for example.
Yeah, 3, 4, and 5 being the first example. And so somebody at some point posed this problem of what's the smallest set of integers where you can't color it in any way such that all of the Pythagorean triples are monochromatic. This mathematical problem was around for a long time. And then somebody at a place called the Texas Advanced Computing Center did this massive computation and figured out that 7,825 was the smallest, or the first integer where you couldn't have a two coloring, where all of the Pythagorean triples were monochromatic. So it's a pretty difficult thing to state. But I think one of the interesting things about it was that the so-called proof of this idea was 200 terabytes of data.
What?
That they compressed down to 68 gigabytes. This is from Wikipedia. It says there are 2 to the 7,825 possible coloring combinations for the numbers up to 7,825. These possible colorings were logically and algorithmically narrowed down to around 1 trillion cases, and those expressed as Boolean satisfiability problems were examined using a sat solver. Creating the proof took about 4 CPU years of computation over a period of 2 days on the Stampede supercomputer at the Texas Advanced Computing Center and generated a 200 terabyte propositional proof, which was compressed to 68 gigabytes.
And the answer is 7825. So all of that, and you dumb it down to this just one number that you try to describe.
Yeah.
So wait a minute. What does it mean to have a favorite number? Like you care about like it means something to you. You're happy when you see it. I mean, I don't have favorite numbers. I just have like random little bits of minutia that I have memorized. Would having like a favorite Unicode, I don't have one. If you had a favorite Unicode code point, would that count as having a favorite number?
I would describe it as being akin to like hearing a phrase of music or hearing like reading like a snippet of poetry that really resonates with you.
Okay.
So it's something that it's not like it's something that you revisit all the time. It's just that when you come across this thing, it makes you happy for a brief moment.
I would guess that there's something like a flash of recognition, that feeling of, oh, I recognize this. And that flash of recognition can be pleasurable in itself, like this pattern in the world, this broader, you're seeing an old friend maybe. I don't know if I ever told a story on this show, but I know I've told you this story before, that I was driving home from work one day and there was this guy driving in the fast lane next to me, and he was just driving like a total asshole. And his license plate, as soon as I saw it, the first character was U and the second character was plus. And I was like, oh, this guy's got a Unicode code point for his personalized license plate. And the Unicode, and I was immediately like, I know that's a Unicode code point, and I'm pretty sure I know what it was. And the Unicode code point was 1F595. And I was like, I guarantee that I know what this is. I took a photo of it and I looked it up at home. I was like, yep, I was right. That guy had the Unicode code point as his personalized license plate in California of the middle finger. So I took a photo of this. I put it on Twitter, and I was like, this guy was driving like a dick. I knew this was a Unicode code point. I was pretty sure I knew what it was in my gut, in my heart. And it turned out I was right. And that is, to my fortune, the only viral tweet I've ever had.
Pretty classy.
Yeah. You don't want to be famous on Twitter, so I got lucky. I nobody ever randomly stumbled across any little bits of garbage I put up there. I asked a friend of mine if he had any favorite numbers, and he laughed at the question, and he was like, "No, what does that say about me?" No, I was like, "Well, I don't have any either." But then my friend said, "Well, the closest thing I have is that I used to have that one Windows XP serial key that everyone knew memorized." And he spit it out. He's like, "It started with FCKGW." I was like, "What are you talking about?" So I looked this up, and Tom's Hardware has a really nice write up on this. There was a developer for Microsoft who worked on Windows, and he wrote the Windows product activation software. And what this thing would do is it would like you'd get a Windows product key when you bought Windows or you bought a computer with Windows. You'd put that product key in, and it would like build this identifier from all the hardware on your machine, CPU, and other whatever characteristics, and then it would phone back to the like main servers that they had and be like, "Yeah, I'm registering." So apparently there was this like well-known Windows XP serial key that got leaked. It was a volume license key, like if you're one of these computer manufacturers and you need to set up Windows on thousands of machines or whatever, you could enter this magical serial and it would not phone home, and it'd be like, "Cool, I trust you, you're good." And so this was like leaked online for years. I didn't know about this. Did you ever pirate Windows? I hated Windows.
Not that anybody can prove.
Yeah, I mean, I will stand here, and say yes. I totally downloaded pirated versions of Windows, and I found product keys, and I put them in there, and then I was like, God, I hate this so much. And then finally, somebody was like, "You probably want Linux," and I was like, "What is that?" "Oh, yes, yes. It turns out I do want that. That is exactly what I want." So I was like, that Windows serial key that he had memorized. He said he didn't remember it anymore. He just remembered the first 5 characters. It reminded me, I don't have any favorite numbers, but I used to have, and honestly, I feel a little abashed admitting this. I used to have a lot of favorite port numbers. It's- I've I feel like very lame saying this out loud, but it was like, like, well, we spun up a ton of Elasticsearch instances like 10 years ago, and I'd be like, "Oh, there it is, my old friend, port 9200." Like I'm gonna talk to my Elasticsearch friend, and I'm gonna put some stuff in it, and I'm gonna ask for stuff back out. It was like a friend of mine, and PostgreSQL 55432. It's like it's just this descending numbers, and then Redis 637. I had all these like favorite port numbers, and I told my buddy this, and he's like, "Oh, you're like John Postel." And you know the name John Postel, Mike? You probably do.
I do, yeah.
Yeah, the name was like sort of familiar, but I didn't know what he was talking about. So in 1972, Vince Cerf, your old coworker there, Mike, at the Supercomputer Center, and John Postel, they're working at UCLA, and they published this RFC 322. You can look this up. The entire content of the thing is this. This is in 1972 now. The network measurement group would like to establish a network standard socket number for a process discard service. Not all hosts need to cooperate. To do this, we need to know which sockets at each host have already been allocated to standard network functions, right? Because we want to like throw away ports, but we need to know who's got one. Okay, tell us which ones you got. What do you got? What ports are you holding in your pockets? Empty your pockets now. So they say at all hosts which permit login for services, socket 1 is the network logger on which ICP may be performed. We would like to catalog other sockets which are supposed to be well known. So we'd appreciate having a note or a phone call from each host technical liaison describing the function and socket numbers of network service programs at each host. The catalog will be published, and we would recommend that it be maintained at NIC network something group, their network group. And they have this return address on the RFC. The return address is Vince Cerf or John Postel at UCLA. This is 1972, March 1972. So then they get all these like presumably phone calls and letters in the mail, and they collect a bunch of these responses. 1972, December of that year, they publish a resulting RFC, which is 433, which starts with this line, just a wonderful line. The first line, quote, "The czar of socket numbers, John Postel, has established the following assignments for socket numbers used for public functions." And then they list all these socket numbers from these different orgs, like UCSD is doing this and UCLA is doing this, and they pretty much all put Telnet on port 1 or whatever. Can you believe that? The czar of socket numbers. That is hilarious.
Somebody had to do it.
So yeah, well-known ports, John Postel. So that's what he was talking about when I was like, yeah, I used to have favorite ports, which again, I feel really embarrassing saying. And my buddy was like, you're like John Postel.
One thing that's interesting about this to me is, so you said this was 72. If you look at RFC 433, which I think is the one that
that's the catalog they published. Yeah, that's after they got the responses.
That was the original catalog. It looks so when I started messing around on the internet, which I guess would have been 1987 or 1988, the well-known ports were kind of listed in a file that you could cat on your Unix system or whatever. Mm-hmm. And I knew the ports for like Telnet and FTP and things like that, and they're different. So by 15 years later, somehow, because it says in here, I think that the Telnet port is socket 1.
Yeah, right. Yeah, in fact, I looked at that too. I looked at RC4. I was like, well, okay, I'm looking for SSH. It's like, wait a minute. There is no SSH. What am I looking for?
Yeah, so somewhere along the line, these were changed because I think FTP was 20 and 21 by then, and Telnet was 23 or something like that. So, but yeah, it is interesting to think that there was a point in time when somebody had to establish those numbers.
And there's no 80 because HTTP didn't even exist, right? And I sort of naively opened 433 and I was like, okay, I'm looking for SSH at port 80. And then I had to, in my brain, be like, what the hell are you talking about? This is 1972. There's no SSH. There's no HTTP. What are you talking about? Get your head together here. Figure it out.
Just as a sort of loop back here, when I was writing socket code in the late 80s and early 90s, when I wanted to make sure I chose a port that wasn't going to be used by one of the well-known services, I always chose port 1729. So just
okay. So you've got some old code running somewhere on these old mainframes.
So another thing that comes up in our world, which is sort of similar to your Windows key thing, is that there's this idea of magic numbers.
I've only ever heard that used pejoratively in code review. Like, you've got a magic number here, which is like saying, I don't know what the hell this number means. 0.04, where did that come from? Some business requirement?
Yeah, that's how it's usually used. Somebody puts an actual literal number in their code instead of a macro or a constant, and nobody knows what it means. And so
there it is on line 1238 or whatever, indented 4 tabs in, and you're like, what the hell does this number even mean? Where did this come from? That's a magic number, my friend.
It is a bad practice, which we discourage. But nonetheless, there is this long history of using magic numbers in various places. If you've ever used the Unix file command, which tells you what type of a file, if you have a file and you're not sure what it is, and you use the file command to have it tell you what type of file that might be, it may be using a magic number.
What? I've used that command. I don't know what you're talking about. I honestly don't know.
It's evolved a lot over the years, but when you have like a binary file and you're not sure what it is and you want to find out, like, is this dangerous? Is this a program? Whatever. You can say file name. And in the early days, there was this list of magic numbers that usually went into a file called Etsy Magic or various other places. And it had numbers that you might look for in that file as like a sequence of bytes.
Like identifiers and stuff, like headers and
stuff in headers. So like if it was an object file or an executable file or some type of special binary file, it might have magic numbers.
That's hilarious. I've never heard of Etsy Magic. That's pretty funny.
It's evolved a lot over the years now, so that if you look at it, it's pretty sophisticated. So like if you do like a man on Magic, it will give you a breakdown, but it does things like regular expression lookups now. It does looks for GUIDs. It looks for sequences of bytes in like both big endian and little endian order and stuff like that.
But I don't have to maintain that crap. That sounds terrible.
One sort of notable variation on magic numbers is what sometimes people call hex speak.
Mm.
I think this is probably best known to Java people. If you look at hexadecimal numbers, there's, you run out of numeric digits and you end up
A
with
through F,
A through F in your numbers.
0 through
And
9.
so people learned that at some point that you could use the letters in hexadecimal to make words. And
Oh, okay. If any words you can make out of the letters A through F in any combination.
I think the first one of these that I came across was dead beef.
I've heard it. So I've heard that before. It used to be, I don't know. I felt like it was a username or something.
It's been used for a lot of things. I think it was originally used by IBM to like mark unused memory, or like the empty memory in core dump files or something like that. I can't remember the exact thing, but it was, just what it sounds like: DEAD BEF. Another pretty well known one is Cafe Babe, or
I've never heard of that one.
CAFEBABE.
If you're a Java dev, do you immediately know this? Is this a thing like all Java devs know?
I think if you're a reasonably experienced Java dev, you probably heard this, but it's a magic number that's used in Java class header files to.
So that should come up in an interview. If I'm interviewing Java developers, I'm like, what does Cafe Babe mean?
Yeah. An experienced Java developer would probably know that.
Terrible interview question right there. It goes into my list of favorite terrible interview questions. Like where would you have a piercing question? It's in there. So I still I have memorized random things over the years. I bet that a lot of people memorize random things. One of the things I memorized was the original publication date. Is this one weird? Of Don DeLillo's novel White Noise. Why did I memorize? I don't know why I memorized that. And then I started using it everywhere on the internet that would ask me for my birthday. I would put in that date. And the reason why was, if you've read Don DeLillo's White Noise, it's this irony of your data defines you, information age stuff. My goal was to frustrate and confuse and annoy all of these places that are trying to collect my actual real data, to lie. That's what I wanted to do. I wanted to have like a fake internet persona cloud following me around. One of the best ways to do it is as a fake birthday. And for years I would get these, and I don't remember entering it into random places. For years I would get these things on the original publication date, the anniversary of White Noise publication. I'd be like, happy birthday from Chili's. And I'd be like, that's right. You're confused, stupid internet.
I think that counts as a favorite number.
A random date? It's not a random date. It's the publication date of this book that I loved.
It gives you joy, as that lady would say.
Yeah, I guess so. I don't see it in the world. January 21st, 1985, and go, oh, yes, there it is. I don't see the Noah buoy numbers in the world and go, there's my favorite buoy. What are you doing out here at the supermarket as the price for, I don't know, something? That flash of recognition you're talking about, I don't have these for these things. And when we start talking about numbers, I think about Benford's years ago. The show Radiolab, they had an episode on Benford's, and it was one of the most mind-blowing. I never heard of Benford's before I heard about it on Radiolab. And if you want to know about Benford's, if you don't know about Benford's law, you should listen to the Radiolab episode, because it took me so long to build up an intuition for what Benford's law is. Benford's law, they call it, is it the law of large numbers? Is that what they call it?
No, that's a different thing.
Oh, there's like another name for it, but I just know it was Benford's. It's like, it talks about the frequency of the first digit of numbers and data sets. Like, why would you think there would be a law that you could assert about the frequency of leading numbers in data sets? So the law says that if you look at an arbitrary number, depending on the data set, a lot of data sets follow this, it's a lot more likely that it's going to start with a 1 than a 9. Why in the hell would that be the case?
Yeah, I think that's what's interesting about it is, if somebody asked you, I think the naive prior assumption would be that any numbers, if you encounter a set of numbers, the digits are going to occur with roughly the same frequency.
Right,
so it's
exactly,
going to be you'd expect without looking at the data that it would be a uniform distribution.
I mean, and the thing about Benford is he just like started collecting all these arbitrary data sets. I don't remember what they were, but it was like population numbers and rainfall totals and I don't know, measurements of coastlines or whatever. I don't know. And he first noticed that they used to have these like logbooks where they would look up the answers to.
Yeah, back in the days before digital calculators, they had tables of logarithms that you could use with your slide rule to calculate logarithms.
Yeah, and calculate means just like go to the page where that one is calculated and look up the answer. And he noticed that the first pages were thumbed a lot more than the latter pages. And his conclusion was maybe there's a lot more numbers that start with one in the world than numbers that start with nine, which is just still like, what are you talking about? That's crazy. But I finally started to develop some intuition for it. It took me like 15 years to start to get a feel. I would think about this all the time. And they use this for fraud. I don't know if you ever seen the show Ozark. Ozark is
Yeah.
a pretty cool show. Yeah, crime show. It's kind of scary, tense. Makes me sweat watching shows like that. But the guy is a money launderer, the main character, and he talks about Benfords a couple of times, and so he knows as a money launderer that if he makes up fake, accounts, fake accounting entries, that if they don't follow Benford's law, it's going to be more obviously fraud. So he has to like follow Benford's law, which means that 30% of the time the numbers should start with one instead of nine, which is a lot rarer. But I finally had this realization. Let's say, for example, you wanted to just add up all of the the attendance numbers for events all over your country. So you got stadia and you got concerts and maybe political rallies and movies and talks and whatever else, right? And so at every venue, you can sort of physically imagine this. There's a door and the doors are closed before the thing starts, and then the doors open and people start coming in. And as they start coming in, the number starts to go up. So the number grows. So the reason why Benford's law makes sense, maybe intuitively, is you have to start at one. And then there's sort of a stickiness. So you start at one, you get to 10, you get to 100. You're growing up. And so the likelihood that you that you reach a number that starts with 9 is less because you're not starting there. I don't know. Like I have a little bit of intuition for it. It still seems just absolutely bonkers to me that there is a probability that governs the leading digit of a number. It just seems so arbitrary, so random, so loony.
Yeah, I think the first place I heard about it was in the context of people trying to do fraudulent accounting or fraudulent tax returns, and as a human being without any prior knowledge, you start making up numbers in these accounts. You just sort of assume that the numbers are going to be more or less randomly randomly distributed, and turns out that in certain data sets that's not the case.
I would bet like listener audience numbers for our show is like that. It follows Benford. So if we tried to lie about how many people were listening, we'd have to lie effectively by taking Benford's law into account.
Yeah, I mean, I think it's important to note that it's not true of every data set. Data sets have to have certain qualities to follow this property, but I think calling it a law is a little bit of a stretch, but it is an interesting phenomenon.
Well, there was some where it's like it has to be measured and not assigned, like an assigned random number, but there are certain assigned numbers like postal codes or something. I can't remember which one. And then it also has to involve a range of orders of magnitude. So it can't be just, like you got to be ones and tens and hundreds and thousands and millions, and then it's more likely to follow. And a larger data set. It's still weird though. Benford's law. There's a really good post on it. A guy who writes under Statistics by Jim. I'll include that here if you want to read more about it. But I would say go listen to that Radiolab episode because it's pretty crazy.
Should we be recommending other podcasts though?
Well, they don't really make Radiolab anymore. Or actually, they do or something. Radiolab's great. We can recommend other podcasts.
Do you think they'll recommend us?
No, will never have heard of us. But they I don't think they make shows anymore. Or maybe they make shows. It's different now. The guy who really made it, who would go nuts with all the sound effects and the music, he left, I think. And then, well, I don't know. I don't want to comment on it now. But the old Radiolab stuff was phenomenal.
I would say that probably now we are the new Radio Lab.
Okay, I hope listeners that you could hear the facetious look on Mike's face as he says that.
Hey man, you got to swing for the fences.
I feel like there's something different about us, Mike. If you've got this favorite number thing, like you got to factor the number, and I don't mean that as I'm not trying to yuck your yum there. You're having fun with the numbers. I don't know why it just doesn't. I think it's that recognition thing. Maybe there are little bits of data that I recognize, and I get a glean of like a flash of like, oh, I recognize something interesting about that. But I don't know. It's never embedded in the. There's no like deeper meaning for me behind numbers typically.
Yeah, I don't know if it's. I mean, I don't think it's exclusive to me, since there
No,
are people who compile these things. I don't know what the difference in appeal is to between the two of us, but
you look at me and it's like when we look at somebody like, oh, that person doesn't appreciate me. They don't like music. Like, whoa, there's a light that's not in your life, my friend. And you're looking at me like that.
well, not exactly. I mean, I remember working with someone once who claimed that she hated music, and that I found to be just mind-boggling. I could not imagine that. It would be. I mean, I also know people who don't really like food. So I've known a couple of people who are really on board with the whole Soylent thing because they just want to get their energy and move on. And I don't understand that either. But that's a whole different category than not being fascinated by numbers.
Yeah. I mean, I don't really like reality TV shows. Aside from that one with engineering failures, I liked that one. That was cool.
I like reality TV shows when they feature people who can actually do things. There used to be one called So You Think You Can Dance that I would watch.
Oh,
because the people could actually dance.
I don't think I've even heard of it.
So you don't have any favorite numbers?
I have none. And I'm trying to figure out if that represents like a sad lack in my life. You know, like there are people who who come across the realization that they can't picture images in their minds. You know, I say apple, I say chair, I say tree. I can picture that in my head. And then they realize they don't do that, and they feel like, whoa, am I missing something? There's sort of a similar feeling for me here, thinking about no favorite numbers. Favorite buoys, though, definitely. National Data Buoy Center, NOAA, you guys are killing it. Love the buoys. Bring back the buoys. More buoys, please.
Do you like the numbers on the buoys?
I love I mean, those buoys are my friends. If I saw that buoy out there, I would be high-fiving that buoy. Yeah, I know you. 73, you're awesome. 46266, the best.
What about lifeguard towers?
Oh, yeah, Tower 32, Tower 37. Yeah, I know about those too. Yeah, because we meet at those. Be like, oh, yeah, we're going to meet Tower 32, meet Tower 37. That's a pretty niche one that probably sub 0.1% of the audience can relate to. How many people in the world have lifeguard tower numbers memorized?
At least 2.
All the people I used to meet at Tower 37.
So one last number, and this is a tricky one. The number is, and I confess I do not know this one, could not reproduce this one off the top of my head, but the number is 606-503-8420.
Is that a phone number?
It sounds like a phone number. It's not a phone number.
Okay.
So there was this thing, I know it's been 5 or 6 years ago now. I got really fascinated by pseudo-random number generators, and I can't remember why now. I'm sure there was a reason. We should probably do an episode on it someday. So I was reading papers and trying to figure out where these things came from. And, there's famously John von Neumann, like many things, invented the first pseudo-random number generator. And it had something to do with the Monte Carlo simulations they were doing during the Second World War for the atomic bomb, nuclear cross-section computations and stuff like that. So I was reading through all these papers, and Knuth has this section in one of his books, The Art of Computer Programming. He's got a section in the second volume, I think, on random number generators, pseudo-random number generators, and the theory of them and how they work and so forth. There's this interesting part where he he tries to develop what he calls a super random number generator. He goes through, in the book, he calls this algorithm K, and it goes through 13 steps of taking a seed number and doing various slicing and dicing and computations to it on the assumption that doing all these complex operations on this number are going to give him a random number at the end. And he's hoping for something that will have a long period, because all pseudo-random number generators eventually start to repeat themselves. But the longer that you can make that period, the better.
Oh, okay.
So he writes this thing which he calls the super random number generator. I think it was probably meant to be somewhat facetious after the fact, but he discovered that this number 606-503-8420, if you use this for the seed of his super random number generator, it immediately returns the same number over and over and over again. So this number is actually a fixed point of this algorithm that he invented to generate random numbers.
Oh, wow. That's kind of funny. It's funny because you would never be able to predict that in advance. But I wonder how he discovered that number. It's just sort of maybe ran computations over a lot of different numbers with a lot of different seeds, I guess.
Yeah, he talks about testing it in this section in the book, which I don't actually have access to the book, but it's been reprinted elsewhere. And he talks about how he tried various seeds and just to see what the period was, and discovered that this one would immediately repeat, which is pretty surprising and interesting.
We read a article in Quanta this week. I read it. I sent it to you. You were like, "Oh yeah, I read that," and it was about topological spaces. It was this really beautiful quote in it. I think it's a Grothendieck quote at the end, and that's what I wanna close with this here. The quote is, "The most beautiful house, that in which the love of the builder is most evident, is not that which is larger or higher than the others. Rather, a house is beautiful if it faithfully reflects the structure and beauty hidden in things." That made me think of all your love about numbers and stuff. Faithfully reflects the structure and beauty hidden in things. And like when I've looked at programs and thought that's a beautiful program, it feels like this is the attribute. It's faithfully reflecting the structure and beauty hidden in the reality that it's trying to model or whatever.
I think that might be a good way to explain my fascination with numbers. Going back to numerology, it feels like something significant is happening there, even though it really probably doesn't have any meaning to the actual world.
I always think of Richard Dreyfuss in Close Encounters of the Third Kind. He builds up this like mound of potatoes on his plate. And he's like, "This means something." And I was thinking, "Yeah, it does, buddy. It's like, this means something." We're all doing that, right?
Although in his case, it actually did mean something. So,
Oh yeah. In my head, I always imagine it as a joke. All right, Mike. Well, this has been Picture Me Coding, the 100th episode. If you've hung out with us for a lot of episodes, we welcome you. Thank you for hanging out with us. Hopefully you're enjoying the show. If you'd like to reach out, you can reach us at podcast@picturemecoding.com. We have a Patreon, as we mentioned. You could support the show, $4 a month. That's that's Picture Me Coding, Patreon. And this has been Erik Aker and Mike Mull. Thanks, Mike.
happy 100 episode. I look forward to the next 100.
Me too. Wow, that sounds like a lot of work. You got it in you? I don't know. I think I do.
I don't think we'll get it done this week, but
Okay.
Eventually.
All right, cool. All right, friends. We will see you again in a couple weeks.
See you next time.
Bye-bye.